Now I'm in frame. Well, thanks for watching. If you're seeing this, I assumed you're subscribed to the channel, and that's hot. We know this thing has no spark. So in this episode is going to be all about ignition. Let's dive into the nuts and bolts. We already know that multiple components have been replaced. There's a new distributor, there's a new ignition control module. Neither of those solve the problem. Let's dive into how the system works. Let's dive into the nuts and bolts. We already know that this has multiple replaced components. New ignition control module, which would be over there, and yes, I'm recording this after I've done more things on it, but for the sake of telling the story and continuity, here we are. New distributor, which is right there. Someone violated rule number 5, no parts lottery. But these new parts apparently didn't solve the trouble, because it doesn't run. 1984, this is modern. Actually has a digital computer. Has a LH fuel injection. L is for air. Luft. Bosch is a German company after all. Pretty much the most important measurement is going to be this guy, which is your I have to look. I think this is still the flapper design, where air actually lifts up a flapper, and depending on that, it changes the resistance value for the computer to know how much air is getting in there. So the most important measurement being air. Now there are two separate systems. We have our fuel injection system, and then we have our ignition system. On a more modern vehicle, they would be combined into a single ECU, but this is old school, so here we are. Single coil. It's basically a transformer. In order to have high enough voltage to jump the spark gap, you need high voltage in tens of thousands, and there's a close relationship between magnetism and electricity. But here we have two distinct systems, but they do rely on each other. The LH fuel injection, the computer needs a signal from here, basically the negative, know how fast the engine's going, it needs that as well. Single coil. Distributor, single coil. Basically, it's just a transformer. That's it. The coil or transformer isolates the input and output. Basically, the input side makes a magnetic field. A change in the magnetic field creates a voltage or current on the output side. Only a change will induce power on the output side. The relationship between the input and output windings affects the voltage. Just as an example, if you have a 1 volt on the input side with 100 windings, and there are 200 windings on the output side, you'll end up with double the voltage, 2 volts, but you'll also split the current. This is fine, because in this case, you just need the spark to ignite the fuel. Switching the coil on and off makes for that change in magnetic field. We need to induce in voltage on the output side. In older vehicle, this was accomplished using points. Points. And if you look on the bottom here, this old system has got points. Basically, there's a cam lobe, and as that spins, it opens up the contact here, which is spring-loaded. You can see that open up. And this is sort of an interesting design. There's 2 sets of points instead of the 1. So interesting. Usually there's yeah, very interesting. Now, points are completely analog and they work great, but they require maintenance. The interval, I think, was like every 10,000 miles or something. Now, the Volvo has electronic, which means instead of those points, inside of our distributor, there is a magnetic pickup. This one has a situation I don't understand. There's 3 wires, not 2, labeled plus, 0, and minus. And it's all solid state. A big NPN transistor does the switching based off of the signal coming from the distributor, which is that small signal. Less maintenance and potential for greater control over spark. Now the Volvo 245, the 245s are a mixed bag. They made this model for so long. The only commonality in it is the basic motor design, the B23 block. I think all the 240s had that. A B23, or there was a 21 foot turbo. There's also a diesel, which is incredibly rare. But since they made this model forever, it's a smorgasbord of what you're going to get. You can get it with points. They had early editions with points. You can get the 2-pin magnetic pickup, the rotor pickup. They have those as well. They also have this 3-pin style. The ignition control module could be a Volvo design. It could be a Bosch ignition control module, and it could even be a Chrysler one. Ew. And they put it in all sorts of different locations. This one had the ignition control module right here. Others had it next to the fuel injection computer in the passenger footwell. Others had it on the driver's side. It could be anything. Now, this is a temporary setup as a proof of concept. The distributor, the proper distributor here, is completely missing a vacuum advance module. How they accomplish vacuum advance in here, I am not sure. Obviously there has vacuum advance. Basically, you need to advance your timing as well engine RPM increases because the fuel needs more of a head start, basically. So degrees before top dead center. Usually 10 degrees is about right. We'll get to that in a moment. I don't understand how it does the advancement, or if it has an advancement. The control module has a vacuum module on it. Not sure what's up with that. The right way is the proper way. This thing has been gone through, and it has a replacement coil here. Let's do some troubleshooting. First of all, we got our meter right here. And we got some power there. We got negative on the battery. Key's not on, so we're not going to have anything here. Let's turn it on and see what happens. Alright, we are ignition on. And that bees the... So on the power side of the cable, I have voltage. But we have no spark. That's going to lead me closer into the distributor. I'd be willing to bet. Now that's not breaking. Actually, that's going to come from the ECU over there. But first we need to see if that ECU is getting signal. And where it's going to get signal from is down in here. See, there's two wires. If you're wondering what those two wires are for, that is simply your signal wires. Back in the day, you used to have points. To make a complex matter simple, I mean, we could also have a bad coil too. But to make a complex matter simple, one thing at a time. We will check the coil, we'll check the rest of this. There is a magnetic, it's like a Hall effect sensor in here. We'd have to pull the whole distributor off to get to her, but it's possible that piece went bad. So we got two wires that go here, and it's not terribly complex. So this one just goes to the ECU. That ECU has some electronics in there. All this is doing is an on and off signal, but it's a very faint on and off signal. Just a Hall effect sensor. The points, if anybody remembers points, they were a pain. They needed to be adjusted every 10,000 miles, and we didn't get them pretty close. Something wasn't going to be running right. So this just puts out a small current of on and off, which then goes to the, I believe that's our control module, would be my guess, since it's been replaced, or control module, ECU, whatever. You can see it's got a new label on it, it's been replaced. So, yeah, and that's why you have these little slots in there. I don't know if you can see that. Let me see if I can zoom in. This is essentially a very rudimentary Hall effect sensor. But these sensors sort of rarely go out. That doesn't happen too often. But we can solve all this. Solve the whole thing. So, one thing at a time though. Essentially, all the ignition control module is doing is switching on and off to make a larger current. Essentially, it's a solenoid, a very fast one, to switch this one on and off so you can essentially get an HEI ignition out of these guys. So, checking this. Further evidence here. Standard GM control module. And that is the exact thing I would do to troubleshoot this issue, so that was brilliant. In fact, I did that exact thing on a, I think it was an 82 Toyota. Look there. So what we're going to do, we got some electrical testing equipment. I'm going to put some stuff back together. We're going to see if we got spark. Best podcast in the West with questionable logos. Voltage there. Excellent. Now let's check another thing here. Let's see if we've got pulse. And it's on all the time? Interesting. Well, that was interesting. The negative stays on all the time. The coil haven't been on all the time. Wipers randomly turn on and off. Problem for a different day. Got pretty toasty. This thing is hot right now. So I pulled off the big ground wire. This guy should be interrupted. And that, of course, goes to the harness here. This is our ECU, just sort of flapping in the breeze up around here. That is also very hot. Jeez. Okay. And luckily, I labeled the thing here. Be the ignition control unit. Made in the US, and that looks like a replacement part, so someone did something interesting there. And could we do... I mean, I'm certain we can, but... oh, I am certain we can. Now, ECU's hot. Cool down here, hot up here, and if I look in there, I've got what appears to be a big MOSFET. What are the chances of having a bad MOSFET? Pretty good, pretty good. And this one I might get lucky on. In fact, wait a minute. Ah, damn wipers. Here, I don't have to worry about it. All right, safety first. So, yeah, hot right down here. No heat here. Hot on the backside, so that's right near that big MOSFET. So let's pull that off here. What I find interesting is obviously this is a newer unit, which was, I think, replaced during troubleshooting. Oh yeah, that is hot. And if you look in there, you can see some burnt on that thing. Let's pull this thing apart. Well, we'd have to melt all this off to do anything with it, but I mean, anything's possible. It's still toasty. Just real quick here on this guy. All this is a very fast switch. It's basically a solenoid. MOSFET, that's just a transistor. Should be a, I'll have to do some more research and see if I can't get that part. No expense was spared. Napa. So, 5-wire, one is a ground. If you have this on a mounting plate, you don't obviously need the ground wire that I rigged up there. W and G go to your magnetic pickup inside of your distributor. Over here, B goes to the battery connection. C goes to coil. How simple is that? So looking at the coil here, that giant gray wire right here. First, let's get our ground. Now I'm in bed, but these are the things that bother me at night. I spent considerable time on this project trying to make the small block Chevy generic ignition control module work with this 3-wire setup on the pickup. It did not work. It did not work. I couldn't figure out how to make it work, and had a few things working against me. One, as I found shortly after this, when I got the distributor and the stock ignition control module on the bench, both of them were bad. I replaced the transistor with the ignition control module, but since I still didn't have a good signal coming from the distributor, that would not work either. Something else that was working against me, the small block Chevy control module here, was also bad. I actually took that over to O'Reilly, and they still have the test machine there, so good on them. And I actually purchased a new one, and since I was hoping to get it sparking and running right then and there, I was willing to pay the markup. It was like $40 the one they could find there. Ridiculous. They sell these for like $6 at Rock Auto, and that's probably the way to go. I mean, for $40, you might as well be getting a Napa unit. So I spent considerable time making mistakes and making this not work. So there'll be some clever editing. I'll skip all this out, and I actually found a way to make that work in a little bit. And to make that work, I actually purchased a junk distributor off of eBay for like $30 from my older model. I think this one ended in '78, but it had the 2-pole pickup like the control module was expecting. Back to my mistakes here. I am at least explaining how one would do this conversion if you should do. And it's a great conversion on applications like this where the control module is unobtainium, which a lot of these are, or very expensive. I mean, for someone just switching on and off for a one-off unit, the eBay price for this was about $250. It's gone down a little bit. When I was first looking, it was $330, but demand, I guess, I don't know. But for applications, instead of buying one of those, and yes, granted, it may not be reliable. I actually looked this up on the Toyota 22R that I was converting to this. I sold it with that module running. But people say it's unreliable, it's junk, it's whatever, but Oh my goodness. I hope the neighbor cat's not fighting the skunk. It's going to be unpleasant for everybody. We've got a porch skunk. Lives under the porch. It's pretty chill usually. Anyway, these modules are less reliable. The small block Chevy ones, people say they're less reliable than the stock modules, which is backed up by the fact that, I mean, some of these modules, like on this one, is going on 35 years old, and it's maybe the first time it's gone bad. On Toyota's same thing, but this works across the board usually if you have a standard style magnetic pickup. But for the price that you're saving, rather than sometimes sending your ignition control module off to be rebuilt, or for really one-off applications for paying an electronics technician to actually reverse it and reverse engineer it and rebuild it for you, which is on extremely rare things, is a thing that you want to do if you're going for a stock application. But for functionality, these things work, and you can keep an extra one in your glove box for the price and still be below what, you know, the standard module would cost you. So 10 out of 10 would recommend. Also, replacement's very easy. It's 4 wires and several bolts. Easy to do. Well, I'm going to let me finish. Well. Well, welcome back to the garage. Been a hot minute. Now, normally be pretty deep in Datsun videos, but since it's raining, I don't want to get wet. I got wet, and it's raining cats and dogs, and that is a blessed sight. Fire season, winter is coming, and fire season is over. But we're back on the Volvo 245, 1984 245. Ignition control module, the thing that was giving us all that trouble before. We're going to see if we can fix the module. I don't know if we can. We're going to see. We'll find out. These things are pretty easy to take apart. See, I already lost 2 of the screws. So I think I've already explained the function of the ignition control module. This has a few additional features, as you can tell by the glob sticking out the end here. Power stage or something they call it. Mine was connected to nothing. And also you can see that this is a remanned unit, not an original piece of equipment. What math is this? This is definitely a remand. You can tell it's from the program people, whoever they are. Country of origin US. So they took a core in, then, oh geez, I don't know what coating that is, but look how it breaks off there. Maybe I shouldn't take all this off. I'll get it off the transistor here, because that, I believe, might be our culprit here. As you can see, it comes in a big blob of heat sink here and stuff. But geez, what chips are these? Hold on. Okay, data sheet. Let's see if I can find that. Oh, I found the RCA 8240 data sheet. Hold on, what is it? It's a boundary scan test device with octal inverting buffers. Great. Great. What does that mean? All right, what do we got here? Got a few more chips here. But the apparatus that's actually doing the switching is going to be this transistor here. And I really hope it is, because if this doesn't work, then, I mean, I'm sort of up a creek short of buying a whole new module. And for these remand modules, I was able to find one with identical labeling of this, eBay, for 350 bucks. For the, that is a different. All right, so when they this was remand, I was on the right path. This is an exciting time, because I had taken this apart previously and just looked at it and saw the giant transistor on there. That's a PNP transistor, I believe. We'll get to more transistors in a second here. And then I saw that and was like, oh, well, that's probably our culprit. So I actually splurged and went ahead. Spent several dollars on this guy. I mean, close. It's really close. It's not the exact fit, but close. Apparently you cannot get these specific transistors. So, see if I can just pull that right off here. I sure can. Yeah, definitely a different stuff there. So in the reman process, it looks like they replaced that transistor, and I see nothing else that was taken off. They also looks like they resoldered the plug on, which is probably good. But let me expose the screws here. Oh, this old stuff just breaks right off. Then we got off all that we're gonna get off. We'll have no choice for desoldering. There's our handy Ryobi unit, cordless. That be's our culprit. I feel a lot better about jumping the gun on buying a new one of these. So let's, can't even see there. While that's heating up, let's get our Phillips here. Own a solder sucker. It's basically like a little pen. You spring it down, then when you're completely off, you pop it up. So on these screws, it looks like, did they just dump a bunch of solder in there? What's in there? I may have to take that out with pliers. Makes me kind of wish I had that solder sucker right now. Yeah, why would the remanufacturer try to secure those screws? I don't get that. What do they gain from it? I mean, the OE manufacturer, I understand there's a financial incentive, but these aren't the only cats doing this. Let's, okay, got both sides off there. Let's loosen our screw a little bit. All right, we got her out. Looking down here, and I think this could be our failure mode. There's absolutely no grease right there. So, let's test this thing. This guy is a PNP. Limit of this guy. To test, you're getting our analog meter. And we are, let's see if I remember this right, ohms. We are going to want to measure ohms between the collector and the emitter. Ah, look at this guy. Has it labeled here. How convenient. The thing is the metal case is the collector, emitter is the left, base is the right. Basically, this is a switch. Base and emitter, let's see our resistance here. Between the two, we got, is that like 30 ohms? Testing our faulty guy. What? Why is that the same? Okay, about 15 ohms between base and... Okay, all right, I got it here. So this has melted on the inside and is shorted in between. So I've got the right resistance between a collector and emitter, about 30 ohms, that I'm happy with. Or between emitter and base. But between collector and base, it goes down to about 15. And between collector and emitter, also about 15. So this guy is bad. We'll get rid of that guy. So now we got to put the new guy in. I need some hot snot for that. Not hot snot, I need thermoelastic paste, whatever. Beautiful. All right. Unfortunately, since I do not know where my thermal paste is, we have a solution here for our lack of thermal paste. Because I did not buy any thermal paste. Nowhere in town has thermal paste. There are no electronic stores anymore. And the hobby stores that have RC stuff and other things also did not have thermal paste. Disappoint. So, we do have some thermal paste in the form of Sensodyne. That's right, this is getting the expensive toothpaste. No expenses were spared. Now, question might be, does toothpaste make a good thermal paste? Obviously, I think so. Ooh, minty fresh. All right, so we got her good here. We got her good. All right, writing goes down. Got ample toothpaste. Let's plop her in. Now at this point, I should be able to get both of them in. Let's see here. For a couple seconds here. Hold on, there we go. My iron's still hot. Get that nice and hot. Let me get you a zoom in there. Does not do macro focusing. So you want a good, it kind of looks like a little TP acorn thing right there. That is where you got the good coverage. And what a mess. This, as you recall before, we have no spark. That is gas. You need gas? But the right way is the wrong way. So that doesn't fit. It takes some getting to get her in there. But she's in there. This uses the standard 2-prong that you have right there. Since apparently the pickup in that, I've discovered, is dead. Test it out on the bench. There'll be a clip there. But let's look at this real quick. So the current setup is the simple 2-prong unit. 2. Not the weird 3 one that's got, that I don't understand, into a Chevy ignition control module. And once again, the wiring on this is pretty simple. WG, those go to the coil. Might have to flip them, I don't know. The base itself is the ground, B goes to battery, C goes to the coil. So this lead right here is always hot, or hot with the key on, so I turn that on. And this is the coil lead. Just crank. All right, that's good. Thank you, honey. All right, which one's ground, which one's, there's just red and there's white. So, great. Thank you. All right. Okay, you saw that. The thing is a pumping. Which leads us to fuel. I'm thinking I'm not getting any fuel up here. Let's see. There's my missing cat. See if we can hear it. All right, turn the key on. Did you turn the key on, honey? Turn it off and back on again. I don't hear the fuel pump. What a mess. No fuel pressure, honey. No fuel pump.
Then you have to take the gas take off.
Well, maybe or maybe not. I don't know. I'd have to see if it's getting electricity back there, obviously, first. It may or may not, because the people that had this before apparently did weird stuff with parts. I don't have much space to work with. Well, that's about as far as I can go. My wireless mic ran out of power. Tells you how long we've been at this. So, well, thanks for watching. We have spark now. We have spark, and that's a big cause for celebration. What a time to be alive. We have spark, and we also have fuel, or we have pulse at the injectors, which I showed you in that last clip there. So things are looking up. This thing's almost ready to start. Next, fuel injection. Fuel. We might be 180 degrees off. I'm not certain. That's possible. We'll get to that problem in a second. It backfires pretty good, which tells me that we're probably 180 degrees off. Basically, the distributor rotor rotates once for every 2 revolutions of the engine, because it's a 4-stroke. So the piston goes down, up and down twice for every power cycle. Now, we need to get over to fuel. I don't think we have any fuel coming up front. I don't hear the fuel pumps running. And also, we've got... I have not gone as far as to check voltage or anything. One thing at a time. But it's sort of a mixed bag, like I mentioned earlier. The fuel injection or the fuel pump relays could be here. They could be on the passenger side. They could be hiding somewhere up there. As I understand, it's usually a green unit. Usually. But something that might be a worry is if this thing has been used for parts, and is that 4 wires for a relay? 5 wires? Yeah, it could be. You need ground power, probably 2 sources, maybe it's a 2-stage. I don't know, but we're going to do some basic electrical testing in episode 3, where we go into the fuel injection system, and at that point, this thing might run. But, and if it should run with that, also these things have 2 fuel pumps. There is a lift pump back there, and there's a pump up here. I believe it's up there. I know they move the locations around a bit, but my pump is definitely not working. So, and once we actually get it to fire and we are able to more closely check the condition of the engine, I may bite the bullet and get the proper rebuild distributor and a proper ignition control module. Because although this setup would work nice, there is some jinkiness to it, as you can see. You're relying on GM here, because that's a GM, just a small block Chevy unit. Nothing fancy or important. It works. They're a bit, I wouldn't say unreliable, but they always die. But for the price, you can afford to have an extra one sitting in your glove box. Yeah, that'd need a heat sink, that'd need more permanent wiring, I need to run the vacuum, and I would like to do things at least somewhat right. I had to do some stuff to make the distributor fit. It is way off. One, it's missing the clip that holds the cap on the other side. That's why that's taped. Also, the where it's supposed to be bolted down, it's not. So we got some free play there. But one thing at a time, and I'd like to do it proper. Unfortunately, that I think they're about $250 a piece. So before I spend $500, do I need both? I don't know. Do I trust my transistor thing with the already remanufactured unit? Also, I don't know. But I'd like to see how she runs, how the transmission's shifting, what sort of compression we got, but anything else that might be broken. This thing also has no brakes at all. The tires are the wrong size. In fact, these don't even fit. We're rubbing on the inside. One thing at a time, so I need to decide if we're getting the actual proper rims or a proper offset rim, or if we're going to be getting wheel spacers. Shudder the thought. So the future of this thing is still very much up for grabs. Now, no more false endings. Well, thanks for watching. Stay tuned with me for episode 3, all about fuel.